Hello and welcome to Mike Academy. So in this video, we're going to be looking at numerical differentiation using the central difference formula. And we're going to be solving two examples in this video to explain this concept. Now let's consider the first question on the board. It says, approximate the first and second derivative of the function y equals 3x ln x using the central difference method at x equals 3. You're given h to be equal to 0.5. Okay, so let's pick out our function. We're given y to be equal to 3x ln x. We're given at x is equal to 3, and then we're given the step size h is equal to 0.5, and we have to approximate the first and second derivative. Okay, so for the first derivative, using the central difference method, remember the formula states dy all over the x equals f of x plus h minus f of x minus h divided by 2h. Meanwhile, y here simply means f of x. So you have f of x equals y, and that is equal to 3x ln x. Now we need to find f of x plus h. Now this simply means f of x plus h simply means f of x is the point of interest, which is 3, plus h there is simply 0.5. So this is actually f of 3.5, because 3 plus 0.5 simply gives us 3.5. Now this means in the given function, wherever you see x, now simply plug in the value as what? 3.5. So in this 3x ln x, wherever you see x, simply plug in the value as 3.5. So you're going to have 3 in place of x, you have 3.5 multiplied by ln 3.5. So this simply implies that f of x plus h is equal to, so I'm going to punch everything together. Do well to punch along to avoid calculation errors. So let's simply obtain 3 multiplies 3.5 multiplies ln 3.5. That gives us approximately 6.8722. 6.8722, and we have this. Now, having found f of x plus h and f of x minus h, we simply plug into the formula. So our derivative, the y all over the x, is going to be equal to f of x plus h gave us 13.1540. So you have 13.1540 minus f of x minus h. That simply gave us 6.8722. 6.8722 divided by 2h, which is 2 times h is 0.5. You have this. So let's compute everything. 13.1540 minus 6.8722. That simply gives us 6.2818. You have 6.2818 divided by 2 times 0.1 is simply 1. So this simply implies that for that given question, our first derivative approximation using the central difference method is simply 6.2818. So having found the first derivative approximation, the next is to find the second derivative approximation according to the question. So remember, using the central difference method, the second derivative approximation, the squared y all over the x squared, formula is simply going to be f of x plus h minus 2f of x plus f of x minus h all over h squared. This is our formula. So we know what f of x plus h is. So we know what f of x plus h is, and we know what f of x minus h is. Let us simply find f of x, right? So we simply find f of x. F of x simply means the value of the function at the point of interest. The point of interest is simply 3. X is equal to 3. So f of x simply means f of 3. This is going to be equal to 3 times 3 multiplied by ln 3. Okay, so let's punch everything together. 3 times 3 multiplies ln 3. That gives us 9.8875 approximately. So we have 9.8875. Okay, so this gives us f of x. Now we simply plug into the formula to obtain our second derivative. So d squared y over the x squared equals f of x plus h. The value is 13.1540. 13.1540 minus 2f of x. And f of x simply gave us here 9.8875. So minus 2 times 9.8875, okay, plus f of x minus h. And f of x minus h gave us 6.8722. So plus 6.8722. The whole of this divided by h squared. H is 0.5 all squared. So d squared y over the x squared is going to be equal to, so I will simply evaluate everything at the numerator, do where to point along to avoid calculation errors. So everything at the numerator gives us 0.2512. 0.2512 divide 0.5 squared simply gives us 0.25. So let's find the ratio 0.2512 divided 0.5 squared. So that simply gives us 1.0048. So this implies that our double derivative, the squared y over the x squared, equals 1.0048 using the central difference approximation method. Okay, so that's it for the first question. Let's dive straight into the second question. Welcome back, guys. So let's consider the second question. It says find the y, the x, and the squared y over the x squared when x equals 0.6. So you're given this table and you're asked to approximate the first and second derivative when x is 0.6. Now, if you take a look at this table, if you exclude the table that contains x and y, let us consider a table with real values, right? So from 0.2 down to 1.0. So this can be broken into, this is 1, 2, 3, 4, 5 places. So it means that you can have the first table, which is the first two, you can have the midpoint, and then you can have the last two. So the first two represents the forward table. Any value that lies between 0.2 and 0.4 is said to be at the forward of the table. In that case, we'll simply use the forward formula to approximate, right? Any value that lies from 0.6 and down to the end of the table, we're simply going to be using the backward formula to what approximate, because this is now at the end of the table. But since we're asked to approximate when x is 0.6, 0.6 is directly at the middle of the table. So you split these two, you have the midpoint, and then you have the last two. So which means we're going to be using the central difference formula to approximate that derivative, which is in fact the essence of this video, right? Now, you already know for the first derivative, this is the formula there, f of x plus h minus f of x minus h all over 2h. So we need to find our h. H, that simply means step size. And step size simply means successive difference in the values of x, right? So it means my h is simply going to be either x2 minus x1 or x3 minus x2 or x4 minus x3 and so on. But you must have a constant value for what? The step size. Okay, so this is going to be equal to x2 there is 0.4 minus x1 is 0.2. This simply gives us what? 0.2. So this means our step size is 0.2. Now, meanwhile, x is the point of interest, which is the point we are approximating our derivative about. And in this case, x is 0.6. So from the formula, let us find f of x plus h. So f of x plus h simply means f of x is the point of interest, which is 0.6, plus h is the step size obtained now, which is 0.2. So this is actually what? F of 0.8, because 0.6 plus 0.2 simply gives us 0.8. So this simply means that, okay, f of x plus h is equal to, this simply means that whenever x is 0.8, what is the value of y from the table? So from the table, when x is 0.8, y is simply 7.87. So this means f of x plus h is simply 7.87. So that is settled, right? Next, from the formula, we find f of x minus h. Okay, so f of x minus h is going to be equal to f of, once again, x is 0.6 point of interest minus h is 0.2. This will give us f of 0.6 minus 0.2 simply gives us 0.4. So f of x minus h is going to be equal to, so this means when x is 0.4, what is y? You look from the table, when x is 0.4, y is simply 3.53. So f of x minus h is simply 3.53. 3. Now you know this, you can simply plug into the formula. Okay, so this is going to be equal to f of x plus h. F of x plus h gave us f of x plus h gave us 7.87. So you have 7.87 minus f of x minus h, that gave us 3.53. So minus 3.53 divides by 2 times the step size, 2 times h, and h itself is 0.2. So divides 2 times 0.2. Okay, so this means the y over the x is going to be equal to, let's find 7.87 minus 3.53. That simply gives us 4.34. So the numerator is simply 4.34 divided by 2 times 0.2 is 0.4. So this simply implies that the first derivative approximation of that table using the central difference formula is going to be, so let's obtain 4.34 divided 0.4. That simply gives us 10.85. So the first derivative approximation is simply 10.85 using the central difference method. Okay, next we'll move on to the second derivative approximation, right? So from the formula, now we know what f of x plus h is. We also know what f of x minus h is. We simply find f of x, right? So we simply find f of x. This is going to be equal to the value of the function at the point of interest. X is 0.6, right? 0.6. So f of x is simply f of 0.6. This is going to be equal to, so you look in the table, when x is 0.6, what is the value of y? 5.75. So y is simply 5.75. Now you plug all the values into the second derivative formula. So you're going to have the squared y over the x squared to be equal to f of x plus h. Okay, we have that here. That is 7.87 minus 2 f of x, and f of x itself is 5.75. So minus 2 into 5.75 plus f of x minus h, and f of x minus h gave us 3.53. So plus 3.53. The whole of this divided by h squared. H is 0.2 all squared. So I'm going to evaluate everything at the numerator altogether just to save time. Do well to punch along with me to avoid calculation errors. So everything at the numerator simply gives us negative 0.1 divided by 0.2 squared is 0.04. So this simply implies that our double derivative, the squared y over the x squared, is going to be equal to, let's find negative 0.1 divided by 0.04. That gives us negative 0.004. So you have negative 0.004. And this becomes the second derivative approximation for that given question. Alright guys, so that's how to employ numerical differentiation using the central difference formula. I hope you found this very interesting and helpful. Please, if you do, I would like you to leave a like, comment nicely, share to your friends, and if you're new to the channel, do well to smash the subscribe button right now and turn on your bell notification so you don't miss out on our subsequent videos when it drops. I will see you in the next video. Thanks.